So let's take a look at, well, let's go ahead and do carbon, okay? And let's say that we want to do carbon, let's say carbon 14. All right. Now, this right here is the mass number. Okay? Can anybody tell me what the mass number represents? What's the mass number going to tell you? Aiden? Not protons and electrons. Brody? Protons and neutrons. Okay, so remember, your mass number represents your two heaviest particles in the atom, the protons and the neutrons. Okay? So the number of protons in carbon, what's the atomic number? C. 6. Okay? So we have 6 protons. All right, and if this is a neutral atom, how many electrons is it going to have? It should also have 6. And then if the mass number is 14, how many neutrons is it going to have? 8, because it should be 14 minus the number of protons, which is 6. So 14 minus 6 is 8. All right, I'm going to go ahead and draw a nucleus on the inside of here. All right. Now, where are the protons going to go in the atom? Where do the protons exist? In the nucleus. So we're going to put 6 protons inside the nucleus right there. So you can just put 6p plus to represent 6 protons. All right. If you forget your symbols, I'll write them up here. So protons, P plus. Neutrons is an N with a little 0 on top of it. And then electrons, you got E, a little negative sign. All right, now, where do your neutrons go? Inside the nucleus. So you should have 8 neutrons inside the nucleus. Okay, 6 protons, 8 neutrons. Everybody with me so far? Anybody not with me? All right. Now, there's a couple things that you need to know about an atom. Okay, so with the atom, you have to think of the atom kind of like a theater. All right, and in a theater, how many of you have ever been to a theater before? Whether to watch a movie, go to a concert, okay, anything like that. All right, so you probably at least have seen one on TV if you've never been to one. But I'm going to draw basically what you can think of with a theater. So let's say that this is like your first section of seats, and then second section might look something like this. All right, third section might look something like this. Okay, so does everybody understand what I'm talking about when I draw that? So you know how it kind of fans out as you get towards the back, and it normally gets a little bit wider. So more people can sit in the back, all right, further from the stage than you can the front, okay, which is closest to the stage. All right, So whenever you think of the atom, I want you to think of the nucleus kind of like the stage. So the closer you are to the nucleus, the less electrons that you can fit, okay, closer to the nucleus. All right? So here's generally our rules, okay? First, excuse me. You ever feel like you like swallowed a feather? Man. All right. So in the first energy level, okay, which would be this first ring right here. So first energy level, it can hold 2 electrons. All right? Can hold 2 electrons. Now, does that mean it has to? Just because the first row of a concert can fit 10 people, does that mean the 10 people are going to be there? Doesn't guarantee it. All right? So the first energy level can hold 2 electrons. It does not have to. Okay? It could just be 1, depending on how many the atom actually has. Now, second energy level. It can hold 8 electrons. Now again, does that guarantee the 8 are going to be there? No, it does not. Okay? It just means it can hold 8. All right, third energy level. It can hold 18 electrons. Anybody want to take a guess at how many the fourth can hold? Not 28.
26.
Not 26.
36.
Not 36.
I said 24.
Not 24.
22. What?
No.
48.
The fourth energy level can hold 32.
I was close. I said 36.
All right? Can hold 32. Okay? And that's really as high as we're going to go.
How many can the fifth hold?
Mm,
64.
it gets complicated after that. So, yeah, I'll just leave it at that. It gets complicated. All right, so here we go. Okay? First energy level can hold 2 electrons. Now, how many electrons does carbon-14 have? Has 6. So, are we going to use the third and fourth energy levels? No, we're not. That's fine. Okay? It's kind of like at a concert. Just because you have seats in the back doesn't mean that they're all going to be filled. All right? It's the same thing with the atom. Just because those energy levels have space does not mean that an electron is likely to be there. Okay? Because some atoms have less electrons than others. All right, here we go. So the first energy level is going to hold 2 electrons. All right? Because we have 6. So the first 2, they are going to fit in the first energy level. And this would be like a concert because the first seats to sell out are always going to be the ones in the front. Okay? So first energy level is always going to be the ones that fill up first. All right? Now, how many more electrons do we have to place? We have 4. Okay? All right, 4 electrons. So go ahead and put those 4 on the second energy level. All right, everybody with me on that? Okay. Go ahead and look over at the second Bohr model. All right, let's do one that's a little bit harder. Let's say you have sodium 23. All right, how many protons does sodium have? Na. Not 23.
Wait, what's that?
Sodium's Na, all the way left side.
11.
11 protons. All right, how many neutrons would it have? 12, because it's 23 minus 11. And how many electrons? Should also have 11 electrons. All right, go ahead, draw our nucleus right here. Okay, we said protons go in the middle. So 11 protons. And then also 12 neutrons. Those go in your nucleus. All right, now we have 11 electrons that we have to place. Okay? So, first 2, again, are going to go in the first energy level. And that fills up the first energy level. So that's it. How many do we have left? 9. Okay? 9 left. Well, the second energy level can only hold 8. Let's go ahead and fill that up. And the third energy level, how many are you going to have left? Just 1. So 1 lonely little electron hanging out there on the 4th energy level. That's it. All right, everybody with me? Go ahead and flip to the next page. All right, we're going to do one that's a little bit easier. Let's say that you have hydrogen 1. All right, in hydrogen 1, how many protons does it have? Just 1. Its atomic number is 1, so it has 1 proton. How many neutrons does it have?
That's a trick question.
You actually had it right the first time. It's actually 0. Okay? Because look, your mass number is 1, and you have 1 proton. So that's the only thing that's contributing to the mass number is that one proton. So there's actually 0 neutrons there. So when you look at hydrogen's nucleus, the only thing that's in it is 1 proton. And how many electrons do you have? 1. So just 1 electron. So this one's pretty easy whenever you draw the Bohr model, because all you have is just 1 proton in the nucleus and then 1 electron in the first energy level. That's it. Yep. All right, we're going to do one more. The Bohr model of chlorine 37. All right, chlorine 37. Chlorine Cl on the periodic table. How many protons is it going to have? Cl, second row from, or second column from the right. So it's going to have 17 protons. All right. How many neutrons? 20. It's 37 minus 17. And how many electrons?
17.
Should also have 17. All right. Draw your nucleus. Put your protons and your neutrons in there. So 17 protons, 20 neutrons. All right, how many electrons are going to go in the first energy level? 2. How many are going to go on the second? 8. And how many do we have left? 7. Where are those going to go? The third energy level. So 1, 2, 3, 4, 5, 6, 7. All right, is everybody with me? Okay. So that's how we draw a Bohr model of the atom. Okay.